Hi comrades, I'm going to go through question 20 even from the AS Chemistry November test now. So this starts off telling you that we've got ethanoic acid. It says ethanoic acid is the main dissolved acid in vinegar. Now part A asks, ethanoic acid is a weak acid. What is meant by acid and what is meant by a weak acid? So an acid is something that donates or releases H plus ions. And a weak acid is one that does this badly. So it only partially dissociates. I spelled dissociates really badly there. Let's just ignore I did that and pretend I can spell. And then we've got our partially dissociates. So you could have said partially ionizes. So releases H plus ions, partially dissociates. Then in part B, we've got an equation to balance. So I'll go through a couple of ways that you could balance equations. We've got aluminium plus our ethanoic acid goes to CH3 CO minus 3Al. Oh, they're not putting the charges in. Plus H2. So I'm a big fan of the left-hand side, right-hand side. We've got 1 aluminium, 2 carbons, 4 hydrogens, 2 oxygens. And on the right-hand side, we've got 1 aluminium, 6 carbons, because this is times by 3, 2 hydrogens, and 2 oxygens. So we can start to look at what we need to balance, and it's the hydrogens and the carbons. Now I would leave the hydrogens till last to balance. And the reason I'd leave the hydrogens till last is because it's all by itself. Same reason I leave aluminiums till as long as I can. Because I can just come to these later on, I can put a number in and they'll balance without then changing anything else. So I'm going to start by looking over if I'm not doing hydrogens and aluminiums, I'm going to do carbons and I'm going to do oxygens. And at the moment, we can see that the carbons balance. Sorry, the carbons don't balance, but the oxygens do. So if I get the carbons to balance, I'm going to need to start off with by putting a 3 here. It changes that to 6, changes my number of hydrogens to 12, and it changes my number. I'm sure people are screaming at me the mistake I've made, which I'll change in a sec, and it changes my number of oxygens here to 6. 2 times 3. I've only counted these hydrogens on this side. There are 3 hydrogens here, times by 3, so plus 2. So actually I've got 11 there. So now looking at this, and go, well, my carbons now balance, my hydrogens don't, and worse, my oxygens don't. So I can try and work this out and get this to fix. That's wrong again for my oxygens. So there's 6 there. So now actually my oxygens do balance. I've definitely made a mistake here. Just looking through, looking at this, because I think I put 1.5 there. That then gets my hydrogens on this side to 12. which gets it all to work. That's the advantage of leaving it till last. Oh, it does allow that in the mark scheme, so that's fine. The other way you may have had to do this is to double all these numbers and to have a 2 here, 6 there, and a 3 there. So the other way you can balance equations is to look at it as blocks. And we've got an aluminium block on the left hand side, CH3COH block. Oh, this is going to be a pain to draw. CH3COO times 3 block with Al and a HH block. And then do the same process again. My aluminiums are fine, so I'm going to get my carbons to balance. And to do that, I'll draw 3 of these. So that's 3 blocks then made up of this. Then that all balances. The only thing that doesn't then is the hydrogen, and I need half a HH block. So if I cut that in half, I'll get half, and that'll balance out as well. So some people prefer the block method. I'm more a fan of left-hand side, right-hand side. In part 2, I've just rubbed it out. It tells you this is a redox reaction. I go back. I don't actually need the balancing numbers. I'll put them on in a sec. And we go through each species we've got here and look at their oxidation. We've got aluminium 0, the CH3COO all combined will be a single negative. Now, the reason I don't have to go into everything on here is because it just goes to CH3COO over here, and all combined, that's single -1, that's all a single -1. All their oxidation states are going to be the same. Then we've got the hydrogen that's +1 on the end. There, on this side, I've then got my aluminium that's +3, and my hydrogen, that is 0, because it's bonded to itself. Even if I put the balancing numbers in here, it doesn't make any difference to the oxidation states. So everything in here is going to be the same over here, which is why I don't have to go into each individual one. So that'll get a bit tricky. But now I can see that aluminium goes from 0 to +3. So it has lost electrons if it's becoming more positive. So that is oxidized. And then hydrogen has gone from +1 to 0. So it's gained electrons. So that is reduced. If you think of oil rig, oxidation is loss, reduction is gain. So that'll be your 2 marks on here. And that's question 20.